Have you ever wondered what if there are more dimensions than the ones we are familiar with? This is not a question for the faint of heart. It's a question that plunges us into the enigma of space-time dimensions. We exist in a world defined by three dimensions of space: length, width, and height. These dimensions shape everything around us, from the smallest atom to the vast stretches of the universe. Alongside these, we experience a fourth dimension, time, which ceaselessly moves us from the past, through the present, and into the future. But what if this isn't the whole story? What if there are more dimensions lurking unseen? This isn't a mere flight of fancy, but a concept proposed by various theories in physics. Some theories suggest as many as 10 or even 26 dimensions. Baffling, isn't it? Let's dive deeper to understand these dimensions and their implications. Imagine living in a two-dimensional world, limited to length and breadth, with no concept of height. Picture yourself as a flat cartoon character, wandering on an infinite plane, forever bound to that surface. You could move forward, backward, or side to side, but the idea of up or down wouldn't exist in your reality. That's a two-dimensional world. But we, humans, live in a world with an added dimension, the third one: height. Imagine that flat world now has an up and a down. Suddenly, you can climb mountains, dive into oceans, and even fly in the sky. It's a whole new world of possibilities, isn't it? Now let's add another dimension, but this one is a bit different. It's not spatial like length, breadth, and height. It's the dimension of time. Without time, everything would happen instantaneously. But fortunately, we live in a reality where time flows, allowing us to have experiences, memories, and the ability to plan for the future. So we live in a four-dimensional world, three of space and one of time. But how do we perceive these dimensions in our daily life? Well, we can easily understand the three spatial dimensions. When you toss a ball, you can see it move in all three dimensions. But time, that's a bit trickier. We can't see time, but we can perceive its passage. When you watch a flower bloom, you're observing time. When you reminisce about the past or plan for the future, you're navigating through the dimension of time. Even when you're just sitting still, you're moving forward in time. Dimensions, whether they are spatial or temporal, are the stage where the drama of life unfolds. They shape our reality, our perceptions, and our experiences. Now what if we told you that there might be more dimensions that we just can't perceive? Theories in physics, like string theory, suggest the existence of more dimensions. This provocative statement opens a fascinating rabbit hole of theoretical perspectives that aim to redefine our understanding of the universe. String theory, for instance, postulates that the fundamental elements of the universe aren't zero-dimensional points, as previously suggested, but rather one-dimensional strings of energy. This theory not only reconciles quantum mechanics with general relativity, but also predicts the existence of 10 dimensions, 4 that we're familiar with, 3 of space and 1 of time, and an additional 6 that are compactified, or hidden from our perception. But string theory isn't the only game in town. Enter M-theory, a unifying framework that encompasses 5 different versions of string theory, and proposes an 11th dimension. This theory posits that our universe is just one of many in a vast multiverse, each potentially with different physical laws and dimensions. The idea of extra dimensions might seem mind-boggling, but it's essential to remember that these aren't dimensions in the everyday sense. We aren't talking about hidden worlds filled with unicorns or dragons. Instead, these are mathematical constructs, abstract spaces that influence the behavior of the particles and forces we observe. So, why can't we perceive these extra dimensions? One popular theory is that they are compactified, folded up on themselves at such tiny scales that they are undetectable to us. Imagine a tightrope walker high above a circus floor. To them, the rope is a one-dimensional line, but to an ant crawling on that rope, a second circular dimension becomes apparent. In a similar vein, these compactified dimensions may be influencing the world around us in ways we're just beginning to understand. They could explain why gravity is so weak compared to other forces, or even provide a framework for understanding dark matter and dark energy. These theories may sound abstract, but they have significant implications for our understanding of the universe. As we continue to peer into the cosmos, these theoretical perspectives serve as a roadmap, guiding our quest to unravel the mysteries of space-time dimensions. The existence of more dimensions could change our understanding of the universe and the laws of physics. Imagine for a moment that we live in a universe with more than the 3 spatial dimensions we're accustomed to. What would this mean for our understanding of gravity, matter, and energy? Well, the implications are staggering. Let's start with gravity. In our three-dimensional world, gravity diminishes with the square of the distance between two objects. But in a universe with additional dimensions, the force of gravity could be diluted, spread out over these extra dimensions. This could explain why gravity is so much weaker than the other fundamental forces, a long-standing puzzle in physics known as the hierarchy problem. Next, consider matter. In the quantum world, particles are described by wave functions, mathematical expressions that describe their properties. These wave functions could extend into additional dimensions, leading to new, potentially observable effects. For instance, particles might be able to move in ways we wouldn't expect in a three-dimensional world, leading to phenomena that we can't yet predict. And what about energy? Energy, like matter, could also be affected by additional dimensions. For example, the extra dimensions could provide new pathways for energy transfer, leading to novel phenomena and potentially even new sources of energy. Perhaps most intriguingly, the existence of additional dimensions could help unify quantum mechanics and general relativity, the two pillars of modern physics that have so far resisted a unified description. Some theories propose that gravity is actually a higher dimensional force, with its apparent weakness in our three-dimensional world being due to its spread over additional dimensions. If true, this would provide a unifying framework that encompasses both the quantum and the cosmic, a dream of physicists for more than a century. While these ideas are fascinating, they are still theoretical and require more research. The journey to uncover the true nature of our universe is far from over, and who knows what exciting discoveries lie just beyond our current understanding. The idea of additional dimensions raises more questions than it answers. As we delve deeper into the concept of space-time dimensions, the mysteries only seem to multiply. While we've made significant strides in understanding the fabric of our reality, there's still a vast ocean of unanswered questions that continues to baffle scientists and researchers worldwide. One of the most prominent questions is, how can we prove the existence of these additional dimensions? The current tools and technology we possess are based on our understanding of the four dimensions, three of space and one of time. To detect or interact with dimensions beyond these, we'd need instruments capable of detecting phenomena that we can't even fathom at present. This leads us to another question: what kind of phenomena would these additional dimensions exhibit? Would they follow the same laws of physics as we know them? Or would they introduce entirely new laws, forces, and particles? These questions are not just theoretical musings, but are at the very heart of our understanding of the universe. We also grapple with the question of where these dimensions exist. Are they compacted into the fabric of space-time as string theory suggests, or are they large and expansive, existing parallel to our own? The answer could fundamentally change our comprehension of the universe. And let's not forget the question of time. If there are indeed additional dimensions, could there be more than one dimension of time? The implications of this alone are mind-boggling and could challenge our concept of causality. Despite these uncertainties, the scientific community remains undeterred. There's a flurry of research being conducted, with scientists employing innovative methods and approaches to probe into the mysteries of these additional dimensions. These include experiments at particle colliders, studies of black holes, and even observations of the cosmic microwave background radiation. Despite the unanswered questions, the exploration of additional dimensions continues to push the boundaries of our understanding. The pursuit of knowledge is a journey, not a destination, and as we continue this journey, we may just uncover the answers to these enigmatic questions, taking us one step closer to understanding the true nature of our reality. The concept of space-time dimensions is a fascinating aspect of modern physics. As we've journeyed through this enigmatic world, we've delved into the intriguing concept of dimensions beyond our familiar three, and how these dimensions intertwine to create the fabric of our universe. We started by unveiling the enigma of space-time dimensions, setting the foundation for our understanding. We then explored various theoretical perspectives, each adding a unique lens to our view of reality. The implications of additional dimensions were discussed, adding layers of complexity to our understanding of the universe, its laws, and its potential. Though the idea of additional dimensions is purely theoretical, it continues to be an active area of research, sparking curiosity and driving innovation. As we've seen, there are still many unanswered questions, mysteries waiting to be unraveled. The journey through the enigmatic world of dimensions is a testament to human curiosity and our quest to understand the universe.